Welcome to the lesson where we're going to take our trigonometry and put it to work for us in Phasor Addition. First, we're going to use a horizontal and vertical chart to break down each of our vectors into horizontal components and vertical components. Once we have the horizontal component and the vertical component of each vector, we can add the horizontal components together, and then we can add the vertical components together. The total of the horizontal components and the total of the vertical components, we will then use Pythagorean theorem to figure out our new resultant vector. So we build the chart. The side adjacent to the angle is the horizontal. So we will use the cosine trigonometric function. And the side opposite the angle is the vertical. So we'll use the sine trigonometric function. We'll have to transpose those. Instead of cosine of the angle theta equals adjacent over hypotenuse, we will cross multiply and bring the hypotenuse up, and we will end up with the cosine of the angle theta times the hypotenuse equals the adjacent. Likewise, with the vertical, our trigonometric formula is the sine of the angle theta equals opposite over hypotenuse. But we know our hypotenuse, that's the vector, so we will transpose that to solve for the opposite. So again, we will cross multiply and move the hypotenuse diagonally in the formula, and we will end up with the sine of theta times the hypotenuse equals the opposite. So the cosine of the angle, 330 degrees, times the hypotenuse, that is 50. And then we have the cosine of 60 degrees, the angle, times the vector hypotenuse, which is 85. Likewise on the vertical, the sine of the angle, 330 degrees, times the hypotenuse, 50. And the sine of 60 times the hypotenuse, 85, will give us the vertical component of that vector. So we'll bring up our calculator and work this through. We'll take the cosine of 330 degrees and multiply that by the hypotenuse, 50, the magnitude of the vector, and that will give us 43.3. Enter that on our horizontal vertical chart. We will take the cosine of 60 and multiply it by 85. Gives us 42.5. We will enter that on our horizontal vertical chart. Then we will add those two horizontals together. 43.3 plus 42.5. And the sum of those horizontals is 85.8. Enter that as the total for our horizontals. And then work on our verticals. Sine of 330 multiplied by 50 gives us a negative 25. Hear that? We'll take the sine of 60 now and multiply it by 85 to get the vertical component of that vector. 73.6. Enter that on our horizontal and vertical chart as the vertical component for that vector. Add those two vertical components together. Again, remembering that our first vector, the vertical component, was a negative 25 plus 73.6 equals 48.6. Enter that on our chart. Those two components, the horizontal component and the vertical component, will make up our resultant vector. We can plot them on the phasor diagram, and as you can see, if we draw them proportionally, you can tell that we're going to be at about a 30-degree angle when this is all said and done. To figure out the resultant phasor, we need to use our Pythagorean theorem. C squared equals a squared plus b squared, or transposed. C equals the square root of a squared plus b squared. So we'll enter those into our calculator. So the square root, open brackets, a is our altitude, 48.6, the vertical is our altitude, squared, plus 85.8 squared, close the brackets. It equals, we end up with 98.6 as our resultant vector, our resultant phasor. We'll plot that vector on the phasor diagram. And then the last thing we need to figure out is the angle. To figure out the angle, we will take the adjacent side over the hypotenuse. We will use our cos function. We will have to transpose it, so we are the inverse cos of the adjacent over the hypotenuse. Second function cos gives us our inverse cos. Open our brackets. 85.8 divided by 98.6. Close our brackets. Hit our equals. We end up with an angle of 29.5 degrees. Enter that on our phasor diagram. So our new resultant vector is 98.6 at 29.5 degrees. Now there's a quicker and an easier way to do phasor addition using your calculator, but you have to put it into complex mode. For your calculators, complex mode is going to be mode 3. So you're going to want to hit your mode button in the top right, and then 3, and then you should see an X and a Y in the top left-hand corner of your screen. But what we want to do is get that into our radian and our theta. So we will have to go second function, 8, and now you should see the R and the theta in the top left corner of the screen. So we'll go back and check our last answer from the horizontal and vertical chart. So I'll put my calculator into complex mode. For me, it's mode 2. As I said, for you, it's mode 3 on the Sharp 520 mode. I'll just go over. You can do it this way as well. You can see that mode 2 is complex mode. So we'll go mode 2. And as I said, you'll see that X and that Y in the top corner. We'll go second function 8, and it converts it to the radian and the theta. So let's enter our phasors and do phasor addition in the calculator. We had 50, and then you'll hit this DMS button, and that gives you the angle, 330 plus 85. DMS gives this little angle symbol here. 85 at 60. Hit our equals, and we should come up with that same answer, 98.6. Now, if we want to find the angle 98.6 is at, we have to go second function, exp to toggle between the angle and the magnitude of the vector. So 29.5 degrees. 98.6 at 29.5 degrees. Perfect. Finally, we'll find the vectorial sum of 3 phasors using our calculator method. Bring up our calculator. We're still in complex mode. So we will enter 15 DMS, 15 at 0 degrees, plus 75, that DMS button at 240 degrees, plus 30 DMS at 120. Hit enter, gives us a magnitude of 54 at a negative 134 degrees. So that negative 134 degrees is taken off the 0 axis. Subtract that from 360 degrees. Take 360 degrees minus 134 gives us an angle of 226 degrees. So counterclockwise around the phasor diagram from 0, we are 226 degrees. Our resultant phasor is 54 at 226 degrees. And that's phasor addition using a horizontal and vertical chart and complex mode on your Sharp 520 calculator.